I'm CK. Tonight we've got a module from ADDAC Systems. It's their 4-voice cluster. I'm very pleased with other VCOs I've made by ADDAC, so we'll see how this one goes. Looks like it might be interesting. Hope you enjoy the video. Inside the bag we have typical stuff. We have a power cable, and we've got some bubble wrap. Unfortunately, I'm not a huge fan of bubble wrap. It doesn't recycle. It's nasty. But I've spoken to Thonk about this, and they do very well with some other things. They have a good paper packaging that I like much better. I was afraid of this. Here's the circuit board, and as you can see, it's got a lot of surface mount components, and they're already surface mounted on the board. I don't get to do that. So it takes a little bit of fun away and also makes the build a lot quicker. This is 2 PCBs. We'll break them apart, of course. So here's the front panel, which gives us an idea of what we're going to be looking at here. I'll even put it right side up. Here's 4 voices, adjustable frequency for each. I think this is frequency modulation on or off. I think that's a switch. There's a decay slew pot there. All of these go into filter, cutoff frequency, attenuator for the input voltages, and a resonance knob, which all comes out here. These are all summed into the filter, and then there's 3 ways to get it out: from the low pass side, band pass side, and high pass side. And then here's the triggers for each of the voices. So it looks like it could be very interesting, even though, again, it's going to be less assembly than I like, but I'm sure I'm probably in the minority on enjoying doing hand surface mount. And in the other bag, the only other bag, we've got our mechanical components. Nothing too shocking there. Jacks, a bunch of pots, switches, piece of solder left over from a previous kit, which I'll get out of there. Spacer, power connector, all that. So again, it looks like a pretty straightforward build. I don't think there's going to be anything much to talk about during that, but we'll see. I'll get the soldering iron heated up and we'll start putting this thing together. It's interesting. The first thing the build guide talks about is soldering these 6 caps on, but obviously they're already installed now. They must have had too many issues with people having problems putting caps on. So now we're just going to do all the pin headers and power connector. So I'm going to go pretty quickly through that, though I am going to snap the boards apart before I start. And of course, again, it's just simple little force, not much. And I will be back in just a second. When I have these break apart boards, I like to get my X-Acto knife and a little piece of sandpaper to neaten up the edge of the boards where the perforations were. And I'm doing this off camera so I don't get it on the workbench. So first thing is pin headers, and we put the male pin headers on this one and the corresponding female pin headers on this one. Of course, that's not the right one there, like so. And then when it goes together, it'll go together like that, with the 2 component sides facing each other. power connector on the back, knobs and so on the front. So I'm going to do one of these just to show you my technique for this. I put the pin header through the circuit board, make sure it's the right one, because since there's a 6, an 8, and a 10, you can fit the 6 or the 8 in the 10 and leave some empty holes, and you just got to watch out for that. Sounds like it'd be a silly mistake to make, but I have certainly made sillier mistakes than that in my lifetime of building stuff. So I will solder one pin, not really caring about whether it's flat on the board or not, even though it actually turned out to be, and then just press down, reheat that solder, and make sure it is completely flush. And it is. Now I don't have to worry about anything, and can solder all the rest of the pins. I'm going to do the same thing with the female pin headers, and there won't be much for me to describe or talk about for that, so I'm going to go set the cameras in fast playback, and you can watch me put these pin headers on pretty fast. So that's the pin headers and the power connector. And one thing you'll notice here, if you build this, is you really need to be careful about these two capacitors, which are right near the power rails. You don't want to touch them with your soldering iron or accidentally bleed solder across onto them, because that would be bad. So just be aware. Now on this board, the next step is to take the spacer, standoff spacer, put the screw through the back of the board. Which screw? Put the screw through the back of the board, run the spacer down on it. As I mentioned, since I don't gig, my gear doesn't move anywhere. If you put this in a traveling case and go to a club or whatever to perform, just throw some Loctite or other thread locking material in there so it doesn't come loose over time. Now we're going to go through and we're going to put the pots on the board, and the build guide author recommends on these potentiometers the support legs have a little kink in them to help lock them into position. The author of this kit recommends straightening them out so it's easier to get them through the board, and I guess I'll do that. Maybe I'll do that, maybe I won't. I'm going to see. I prefer to keep the little lock tabs bent simply because it makes it easier for me to not have to worry about it when I'm soldering. So that locks in. So you can choose to straighten them out, or you can do what I do and just kind of shove them on through there. So there are, trying to understand what he's saying here. Oh, okay, there are two different pot types. There's the continuous, like so, and then, and I'll try and find one. That's continuous. Oh, and then there are these, which have a small detent in the middle, so you can get to absolute middle easily. You can feel it. So we'll separate the potentiometers into middle detent and continuous. I think there are only two middle detent, or as the kit author says, middle stop. but it's a very gentle stop. And maybe there is only one. Yeah, I guess there's only one. And there's one B103 middle stop, and there's one B103 no stop, which is there, because we've got all the 100Ks, that's the 104s, and the 103s, which are the 10Ks. So let's get these all put on, and again I'm going to go back into rapid motion replay to put all these on. Now we'll drop all the switches in and then finally get all the jacks situated. We've got two different types of jacks. We've got, and you can tell the difference two ways. Oops, let's not have this fall over. Zoom in just a hair here. Oops. Get my viewfinder. So as you can see, the hole pattern for these jacks corresponds to these silver sliders, and the input and output, or the output from the filter, are your standard inline 3s. So just pay attention to that, of course. I mean, obviously you can't really get it wrong because they won't fit, but if you get frustrated saying why aren't these fitting, that's because you've got two different types of jacks going on. So all the jacks are on. Next we'll put the panel on top of it all to stabilize all the components. This may look like a bit of a pain, but I've certainly had worse or more complicated panels to put on. I'm going to switch all these the right same direction so I can get the angle the same as we come down. Switches are the hardest thing to get through the panel just simply because they're not vertical by design, they're at an angle. Now we'll get all these jacks adjusted perfectly. Come on, guys. Here we go. Almost all snug down. We just got to get the last of the output jacks there. There we go. Well, that's interesting. That's not... So as you can see here, I'm double checking this to make sure I didn't miss anything, but I didn't. There's no support at this end, so the height, the distance between the circuit board and the panel is defined by the height of the jacks. And this is kind of loose. There's nothing holding that up. So that's simply going to be stabilized when the jacks are all screwed down and in place. In fact, I'm not a big fan of that. So 1, 2, 3, 4. I'm counting, and actually there's only 3 threaded ones here, so the security of the panel to the circuit board is very, very not, I mean, the switches also have some role in securing it, but it's not ideal. I like a front panel that's got a little more security than this is showing. But I'm just going to go ahead and put it together the way ADDAC made it. Actually, I'm not. I'm sorry. What I'm going to do is I'm going to go dig out a second screw to put on this switch so I can have that act as a little standoff spacer here, so it's not as wobbly. I just don't like it being wobbly, so I'm going to go off camera, dig through my parts, and get a screw nut that goes on there. So I didn't grab a nut, I grabbed 3 washers, and we'll see if it takes 2 or 3 washers to provide the support I'm looking for. That just means I have to mess with this panel on and off a couple more times, but that's okay to get it the way I would like it to be. Oh, and I switched it. Oh, three washers looks like it's going to be perfect, but I want to be sure. Okay, 3 washers. And the jacks, let me do some measuring here. It's 20 millimeters. And at the other, wait, let me get this right. Okay, 3 looks like I may not be getting what I want, because back here we're at 16 millimeters to the middle of the PCB, and up here we're actually about the same, but I don't have any threads to grip on the switch shafts, so I'm going to take one of the washers off. And again, you don't need to do this. I'm doing this simply because I don't want this end of the PCB, or this end of the front panel, to have so little support. It just does not suit my mechanical engineering brain very well. There we go. I think that will be close to, that's gone. Yeah, that's good. Gives me enough threads, and it's got support. It's pretty parallel. I'm pretty happy with that. Okay, so I'm going to I'm sorry, I'm still not happy with this. And it's not the switch now. As you can see, again, the distance between the PCB and the front panel is driven by these jacks, the ones that take trigger inputs and so on. But with it pushed down as far as you can on that, I've got no threads left on the I/O jacks. So when I put the screws on there, they're going to barely grip, because I've only got about 2 threads to grip to, and that's not good. Yeah, I've seen better. And of course, if you seat them all the way, then you don't have any threads at all. So what I may have to do is I may have to pop them up a little bit. God, I don't like doing that, because then we have less contact material coming through the screw holes. But I think I'm going to have to, the solder holes, I think I'm going to have to do that to give any kind of mechanical support to this PCB and panel combination Yeah, I like previous stuff I've done from ADDAC, but I'm not a big fan of the way this panel goes on this one. And I'm going to have to put all the screws on, the panel nuts on, so that I'm pulling the jack up enough that the solder legs are at the position they're going to be in finally. Yeah, this is not my favorite design that I've run into. Where did I put my other panel nut? There it is. Now, as you can see, they did include 2 screws for each of the switches, so I don't have to, 2 nuts for each of the switches, so I don't have to use those washers. But I'm just going to do what I'm doing here. I've already got it put together. So let me tack one of these legs down. And one of the middle legs down. So that's secure, and I'm going to put one of the nuts on this switch. Secure that and tack one of those legs down. Now I'm going to go back into fast motion and solder all these legs. And that's all the control soldering. I'm just double checking because there's so many that something might have gotten missed. And I will point out again, there are surface mount components very close to many of these solder points, so just be really careful with your soldering iron and don't slop a lot of solder around. So that's that part of the build, and I'm going to pause the cameras because the cat's got to get fed. Okay, I'm going to put all the panel nuts all on. Now, let's see, there's something else that I don't really understand right here. We've got this 90-degree pin header, and we've got these 3 pads here. I want to see how this goes. So we've got to put this on here, like so, I guess. Again, this doesn't make a lot of sense to me. And then we've got a jumper wire that goes from here to here, and I don't know, I mean, I didn't see a piece of wire to do that with. Obviously I've got tons of wire lying around, so it's not that big a deal, but I really don't know what these things are for. They must be, I mean, this must be a common ground, even though I don't know why he didn't use a pin on the pin header to do that, and why we have to run a separate wire through there. This, though, I really don't understand what the heck it's for. But I'll put it on. Again, it seems somewhat clumsy because there aren't wires for it. So how am I going to do this? I mean, there aren't circuit board holes for it, so how am I going to do this? Well, I'll go ahead and treat it like a surface mount component and lay a solder pad down, hold it with my tweezers, try and hold it with my tweezers evenly, and heat the little, God bless America, this thing is just being a pain. I'm going to use needle nose instead because the tweezers are not gripping it tightly enough. Okay, I'm going to heat that little solder pad that I just put down up again. Oops, bless this stupid thing. Again, there's nothing that connects to this, so I don't really know why I'm putting this on here. The instructions certainly don't indicate what this 90-degree three-prong thing is for. And then we've got a wire to go through there, which I'm going to get an old resistor lead, which is why you always save resistor leads. I'm going to have it up high because I don't know the exact distance yet. That's just temporarily there. Glob a little more solder on it. And stand it up. Of course it's hot, but that's okay. I don't mind burning myself. I do it all the time. Now we put the back panel on, and of course I was an idiot and I screwed this on the wrong side, so the spacer's on the wrong side, and with the front panel on I can't put the screw on, but I don't care. I don't particularly care about it being secure. You probably will, because you may be using it in a traveling rack or something you take on the road. I will never take it out of the studio, so it doesn't matter to me. It's not going to get trounced around much. So we've got all this going together. This one's not quite making it. There we go, that's started. I got to get this wire through the hole again. And there we go. All secure there, all tucked in there. Now I'll solder that little wire. Put the power cable on. And that's the board, that's the build. Side view, back view, other side view, top and bottom. Now we'll go ahead and put it in the rack and see what it sounds like. Oh, I'm sorry. See, there's this jumper here. This jumper allows you to route your external in through the filter or through the voices. Okay, I'm going to go ahead and put it in the rack. Alright, so we're plugged in, and I've got my ADSR going into my multi, which is feeding the trigger. So the decays, when they're all counterclockwise, are effectively mutes. So I've got voice 1 as on, and we'll see how it sounds. Sounds okay. Let's take the frequency down. That's coming out of band pass. Let's go high pass, low pass. I'll change the filter cutoff. There, that's all the way out, taking all the low out. Now we'll go higher. And attenuate. See if we can get some resonance going. I don't know if I'm going to be able to do that. There it goes. So that works out fine. Let's turn frequency modulation on. Okay, now the next thing I'm going to do is I'm going to plug in, that's not going to reach. I'm going to go ahead and trigger, let's see, I want to try this first, so, no, I don't need to try that, never mind. So I'm going to trigger number 2 also, and we'll take the decay up. So now we've got both voices running. I'm going to go back to band pass. And of course you can effectively the decay acts almost like a mixer. Let me get a couple more cables and I'll get at least 3 voices in. I'm going to need that. Now, of course, since it doesn't actually allow you to send CV, take both of these down, and that's voice 3 right now, and I can take frequency mod out of that. Let me do one more. I'll get voice 4 plugged in to so we can get all of them fired up. So as you can imagine, since there's no CV, note CV available on this, there's a little bit of a, I mean, you may want to tend this to just be a drone kind of thing. I'm going to go cut off CV. I'm going to take my LFO and put it in cutoff CV. I'm going to take the attenuator out. Take the cutoff up so it's not completely gone. Now, I don't know if the LFO will trigger, so let me try that. I'm going to take everything. Oh yeah, it definitely is triggering. See if I can hit a good resonance point. So as you can imagine, this is pretty good for drones, but since it's got fixed note value at firing, then it's a little harder. I'm plugging it into the sequencer. I'm going to go from the LFO to cutoff again. Switch over to high pass. Take the cutoff out again. Gonna go back to low pass. So you can do interesting things. So that's what it does. So you've got all the four voices interacting with each other, taking them in and out with the decay, bringing in frequency modulation, having an LFO provide trigger or cutoff CV is also very handy. And again, it feels like it's a good background drone-y kind of thing. I don't think I'd ever use this melodically, but it's got a lot of value for that. So again, pretty straightforward build except for all the surface mount already being done for you, which made me sad. But other than that, easy to put together and an interesting drone for your studio. Hope you enjoyed the video.